screen up here. So, over here on this left side, if you can see it, these represent the lengths of the legs of this triangle. So this bottom one, AC, is 15, AB is 9, and BC is 16 units long. That's what all that means. And on Desmos, it's kind of cool because it lets you manipulate all these things. So today we're going to eventually learn what needs to be true of our three side lengths for it to form a triangle. So, what do you guys think? Do you have any guesses or conjectures of what needs to be true? Gabe? Yep, so I'd have to connect my B's here. So a length of 15, 9, and 16 works. Okay, so let's look at this. What do I know about 9 and 16 compared to 15? Do we know anything? Yes, that is very true. But let's say if I added them together, are they bigger than 15? What's 9 plus 16? 25, right? Is that bigger than 15? Okay, let's see if we make them smaller than 15. So I'm going to change this guy to 4. Can I make a triangle? We're going to get close. Oh. Do my B's touch? Do I end up making a triangle? No. Okay, what if they both equal 15? So what if I move this to 6? It might be equilateral. Here we go. It just pancakes. It makes just a straight line. So what we just kind of demonstrated there is the two smaller sides have to add to be bigger than the third to make a triangle. Then it would work. We'll go 6.2, but it should work. And if it doesn't, it's my fault for not having steady hands.
Wow, that is crazy.
Math is cool. It would work if I could be more accurate. Anywho, let's go to our notes. That's what we're doing today. And that is called the triangle inequality theorem. A triangle exists if the sum of the two smaller sides is greater than the third.
No.
So let's try a few examples here. It says determine if the following side lengths could form a triangle. Prove with an inequality. So this is all we're doing.
True.
What are my two smaller sides here? So you're going to take 8 plus 17, and we hope it's greater than 24. What's 8 plus 17? Is 25 greater than 24? So I'm going to put true. So, yes, a triangle can be formed. It works. What are my two smaller sides on number 2?
No.
Is 6 greater than 7? False. That's not true. So no, it doesn't work. Now let's try this last one. 11 plus 4. Is that greater than 15?
No, it's equal.
Right. So this would just make a big line. It wouldn't like pop up for a triangle. So that is false. It's not greater than, so no. Okay, so let's pretend we want to find a third side or a range for our triangle. So we don't know what our third possible side could be, so we're going to write a range. So it could be between this number and this number. And how you do that is, given the two sides you know, find the difference means to what? Subtract. And then the sum needs to add. That's all we're doing. Okay? So we're going to write a range of values. So given 14 and 20, let's find a range of values for what the third possible side could be. So let's find our lower bound. So I need to what? Subtract. So 20 minus 14, 6. And then 20 plus 14, 34. You can form a triangle with any number that falls between 6 and 34. 7, 22, 31.5. Any number that goes between those two ranges. How about you guys try 5 and 6 on your own? If you haven't already. Find the range for a possible third side. Anyone want to come to the board for 5? Agreed? Yep. Anyone want to come do 6? Guys, liven up. It's Friday. We made it to the end of the week. Okay, what's your lower bound on 6?
9.
9. What's your upper bound?
0.5.
Good work. So that's how you find the range of your third possible side. And then, of course, we have to make things kind of interesting and throw some algebra in the mix. Yeah. So we just have some random triangle, right? ABC. So we have no idea which sides are the smaller sides. So we have to check all possible solutions. So let's see here. Let's write them all before we solve. So what if A and B were, or A, B, and BC were our two smaller sides? So we're going to write AB plus BC needs to be what than AC? Greater than. That's one option. I'm just going to be systematic about it. What if BC plus AC needs to be greater than AB? And then our last possible AC plus what?
AB.
Needs to be greater than BC. Okay, so now we know what our options are. Now let's plug back in and find out what x could be. Okay. So for this one, what's AB?
4x plus 25.
Yep, we're just going to plug in. BC is 3x minus 2. Needs to be bigger than 9x minus 5. Bless you. Now from here, let's just add our like terms. I should have an x with it. So 4x plus 3x should be 7x. 25. Yep. Minus 27 is minus 2.
It's not 27. That's the greater.
Oh, look, I can't even read my own handwriting. Da, 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 da. So we should 23. 23. All right, now let's bring our x's to one side. So I'm going to subtract 7x over here and add 5 over here. So x, what do we get when we divide by 2? 14 is greater than x. And then I'm kind of weird. I like to put my x first, so I'm going to have x is less than 14. Just because that's how I read things. Okay. Now we got to do it again for BC plus AC is greater than AB. Let's plug in. I'll try to make my greater than symbols better. Add our like terms. I'm hoping we all got x is greater than 4.
Yeah.
We're allowed to move the x to the other side.
For me, I subtracted 4x down here.
Well, I mean, we can move the x to either side.
Yep. Yep. You can move x whatever way you want. I usually try to keep it positive. That's how my brain works. Anyone confused on x is greater than 4? Okay, let's do the green set, and then we can talk about how we write our range. So x is what? Greater than negative 2.2? Is that what you guys got? Why don't you guys look up here so I know you're done when you're done writing all that. So I'm going to talk about one more thing on how to solve this. Okay, now to figure out our lower bound and upper bound, we need to graph these inequalities, so make yourself a little number line. And we're going to plot some points. If I start with my blue inequality, it says x is less than 14. So I'm going to put 14 somewhere over here. I have an open circle, and if I want numbers less than 14, is that to the left or to the right? To the left. So now we're going to go like this. So that's step 1. Step 2 would be our red inequality. So x is greater than 4. I'm going to put 4 somewhere on our number line. And if I want what number is bigger than 4, what way is our line going to go?
Right.
To the right. Then our last one, x is greater than negative 2.2. What way is my line going to go? To the right. So for an inequality, you look where all lines intersect. So this area right here, you guys see that's where all 3 lines are? So then our range would be between 4 and, perfect. Your homework seems like a lot, but I promise you you're going to get done in no time at all. Leave that up. You have the front of this worksheet, and then I think like 10 or so problems in the book. Will you just please do that in the back of this for me? That would be great. Will you bring them back to the back of that? Okay, alright.
Just the word.